Hi there. Welcome to this tutorial on core Java interview questions from javainterview.in. We have a big collection of a number of videos and our interview companion guide. Check out our website as well. Let's get started. In this video, let's look at following interview questions. We would start off with getting a general idea about the Java platform. What is platform independence? What are the differences between C++ and Java? And then we would move on to things like wrapper classes, and then we would discuss things like toString method, equals, and stuff like that, hashcode, and a little bit of variables. And then look at little bit at arrays. One of the important questions, or not really the important question, one of the things which I ask people, I ask candidates who attend the interviews at the start is, why do you think Java is popular? That really gives an idea about the programmer for me. I just kind of get a sense into what the programmer is thinking about. So for me, the two important reasons why Java are popular are it's a platform independence. It's great. The fact that you can run a Java program, you can compile it once, generate a EAR or a var or a jar, and you can run it anywhere on any device. That's a great feature. The second important thing for me is object-oriented programming. There were object-oriented languages before Java as well. C++, for example. But Java is also really popular. I think these are the two reasons: platform independence and object-oriented language. The next thing which we would look at is platform independence in depth. What is platform independence? Basically, what platform independence means is I can compile the Java program. I can generate the bytecode for the Java program. Here the first class is the bytecode. Is the compiled output from a Java compiler or an interpreter, or it can be a jar file, or it can be an EAR file. The great thing about Java is you can take this file and you can really run it on any operating system. I can run it on Windows, I can run it on Mac, Unix, and Linux. How does the magic happen? The magic happens through something called a JVM. JVM stands for Java Virtual Machine. The JVM does the magic of converting the bytecode to the format which is understandable by the operating system. The actual problem with writing platform independent, developing platform independent languages is that the language that Windows understands is different from the language, different from the language that Mac understands. By language here, I really mean the in-depth binary codes that Windows uses is different from the assembly language of Windows is different from the assembly language of Mac, and so on. So Unix is different from Linux. So that's where the JVM comes in. There is one JVM for every operating system. So, what I mean is there is one JVM per operating system. So the JVM for Windows is different from the JVM for Mac. JVM for Unix is different from the JVM for Linux. What the JVM for that particular operating system does is convert the bytecode, is convert the Java representation of this particular code, that is bytecode, into the object, into the format which is understandable by that particular operating system. So once I install a JVM, once I take a JVM and I install it on a particular operating system, then I would be able to compile, I would be able to run the compiled Java code. That's basically the beauty of platform independence. For me, the real reason why Java is so famous is because it's one of the very first platform independent languages. You can write a Java program on a Mac system, take the class file, and run it on a Unix system. All that you need to do is install the JVM for Unix. So that's really great. Next, we will discuss what are the important differences between C++ and Java. The major difference for me is C++ is not really platform independent, whereas Java is. And also, I wouldn't be able to call Java a pure object-oriented language because there are things like variables. I can create the basic variable types like int or char, which are not really objects. So I mean, I wouldn't really be able to call it a pure object-oriented language, but it's more purer than C++. Let's put it that way. In Java, I won't be able to do any structured programming at all, but C++ allows that. So that's a difference between Java and C++. The next one is C++ has pointers. I mean, same as C. I mean, it has pointers where you can use, I mean, you can directly access the content of internal memory using these pointers, whereas Java has no concepts called pointers. Therefore, Java programs are much more secure. With C++, you can access the memory. I mean, you can try and, I mean, there are ways to avoid it, I mean, which makes it really complex. But Java is much more secure. It doesn't really access, I mean, a program would not be able to access anything other than what's really allowed for it. The next important one is that in C++, a programmer has to do all the memory management himself. He has to write the code to create an object, allocate memory to it, remove memory from it, and all that kind of stuff. Whereas in Java, most of this stuff is taken care of by the JVM. The programmer has to just focus on creating the object. JVM takes care of giving it memory, and once the object is out of scope, it makes sure that it's garbage collected as well. So that's another reason why programming with Java is much more simpler. The other difference is multiple inheritance. Whereas C++ supports multiple inheritance, Java doesn't. I mean, there are people who say Java also supports multiple inheritance because there are interfaces and I can implement multiple interfaces, but not really. I mean, interfaces are not the same as extension inheritance. So having the feature to extend multiple interfaces doesn't really mean multiple inheritance for me. So there you go. Those are the 5 important differences between C++ and Java. Next thing we'll talk about is the role of class loaders in Java. Java program is made up of number of classes. I mean, most of them are written by us, or actually some of them are written by us, and most of them are already written for us as part of the JDK. So I mean, who takes care of making sure that the appropriate classes are loaded when needed? I mean, when I do an import, who takes care of making them available? And when I do an import, how does Java know where to find them? And that's where the concept of class loader comes in. I mean, we configure class path variable with a set of jars. That's the way we tell the Java, I mean JVM, where to find the classes. So the definition of defining class path is also part of the class loaders as such. So let's look at what are the different things about class loader. If you look at the class loaders, the hierarchy of class loaders starts from the system class loader. Next is the extension class loader, and next is the bootstrap class loader. The role of the system class loader is to load everything in the class path. So I mean, whatever we configure as the class path, I mean, whatever we put in the EAR, var, whatever is available in the class path, that is what is loaded by system class loader. The role of the extension class loader is to load all the classes which are in the ext, I mean the extension directories. You can configure the extension directory. Typically it's jre/lib/ext, I mean in the folder where Java is installed. So this is the extension class loader. This is where the extension class loader looks for classes. And the bootstrap class loader is the basic one. I mean, that's the one which loads all the files, all the class files which are part of the JDK. So those are the core libraries. It's like your system class or any of the things which are directly offered by Java. For example, your collection classes and all that kind of stuff, which are the basic things from Java. Whenever the JVM needs to find a file, the first thing it does is find a class. The first thing it does is goes to the system class loader and asks, can you find this file for me? I mean, can you find this class for me? System class loader checks the class path and says, oh no, this is not really with me. Let's go to the extension class loader. The extension class loader then checks its path and sees if it's available there. If it's not, it delegates it to the bootstrap class loader, and it flows down in the same order again. So that's how Java searches for classes, And that's the importance of class loader. Class loader helps you to load classes, load all the different classes, and make them available to the JVM. The next thing we'll look at is the wrapper classes. The basic data types that Java has are int, long, short, boolean, byte, char, double, and float. Like in addition to these basic types, Java also provides immutable wrapper classes around them. These wrapper classes are just an extension to the primitive variable types, and they provide a little bit of functionality. They provide a number of methods which you can use to create these wrapper classes, convert from one of these wrapper classes to another, and all that kind of stuff. So the wrapper classes are available for each of the primitive types. The only only thing probably you would not be very evident is char is character and int is integer. I think the way you create a like wrapper class is the same as any object. You pass the value to it, and you can pass a string value. You can pass. There are different notations that you can use. You can look up the guide for all the different possibilities that you can use to create a wrapper class. One of the most important things about these wrapper classes is these wrapper classes are immutable. What I mean by immutable is once they are created, the value cannot be changed. So if I have to change the value, a new wrapper object is created. You will not be able to change the value of the existing object. Wrapper classes offer a lot of utility methods. You can get, for example, a value of method. This helps you to convert like this 111 from binary to a integer. You can like read from a string using value of. There are also different conversion methods which are available. So int value, float value, a lot of these things are part of the guide. You can really check them out. There are also parse methods, toString methods to convert the wrapper to a string, and also methods available to convert from one format to another format, from hex to binary, binary to octal. So basically the way you can think about a wrapper class is it's a wrapper over the primitive, and there are a few additional functionalities that are available with these wrapper classes, which makes it easy to do certain operations with primitive classes. An important interview question about wrapper classes is AutoBoxing. What is AutoBoxing? Basically, wherever you can use a wrapper class, you can use a primitive, and the conversion from the primitive to the wrapper class, that's directly done by the Java compiler or the JVM. So that's called AutoBoxing. So what happens is, if think of code like this. So what I'm doing is integer 9c is equal to 9. So here I'm taking a primitive and I'm assigning it to a wrapper class. The conversion here is done by the JVM, and it makes the conversion from the primitive to the wrapper class. That is basically what is called AutoBoxing. The next question is about strings. There's a video on our channel which you can look up for all the topics related to string in great detail. Here we'll talk about immutability of string. I mean, what do we mean by immutability of this string is that the value of a string once created will not be changed. So here we have a small piece of code, str3 is equal to value 1, str3.concat value 2. When you print the value of str3, you would see that the value is still value 1, because the operations which are available on this string don't change the value of the string at all. What they do is they create a new object and it's returned back. So you should create a new string, concat is equal to str3.concat value 2, and get the value of it, and then you can print it. That's when you get value 1 and value 2. So all strings are really immutable, and also strings are stored in a specific constant pool called string constant pool in memory, and a compiler does make an effort to find a string literal from it, because the string values cannot be modified. If there's an existing thing in the string constant pool, the compiler, the JVM can find it and return it back to you, and it can be reused. The different utility methods which are present in string class are length. You can find the character at a certain position. You can do a toString on any object, and you can do a comparison of equals. and you also have a substring method. This is the starting character, and you can also have a substring from this character to this character. So those are the different utility methods which are present in this string class. ToString is a very important method in Java. Let's say I have this class animal. I have a constructor, name and type is passed as arguments to it, and I'm not really making them private here. Just to focus on the problem at hand. Ideally, these should have been private variables. What we are trying to do in here is we want to print the content of animal. So when I do a system.out.println of animal, I want to print the name and the type of animal. If I directly run this piece of code, which I'm showing in here, I'm creating an instance of animal and trying to do a system.out.println animal. It actually prints some reference, probably some memory reference, and it says com.retoos.animal and some memory reference. It's some object reference. It doesn't really make sense to me. So if I want to really print Tommy and dog, the way I can do that is by implementing the toString method. The toString method helps to convert the object to string. And whenever you try to use this object in a place where a string needs to be used, like for example, when you're trying to print it to the log, when you're trying to print it to the console, then the toString method is directly invoked. When you're concatenating an object with another object, the toString is directly called. So here, if I implement the toString method and then run this piece of code, you would see that the output actually shows the real content of the object. So it shows animal, the name is Tommy, and the type is dog. The next important method inside the object class is equals method. Equals method is used to compare one object with another object. So let's see how we implement a equals method. So this is the signature of the equals method, public boolean equals, and it accepts object and not this class. So the equals method should accept object and not client. So that's the one important thing. So the equals method is on an object, so you can compare this particular object, whenever you can create an instance of it, with any object. It doesn't need to be an object of this type. And then I'm doing a typecasting, and then we are comparing the IDs. If the IDs match, then they are equal. If they are not equal. So that's basically the importance of equals method. One important thing to consider while talking about the equals method is you need to make sure that you also implement the hashcode method appropriately. So a hashcode method has to be implemented when you also implement the equals method, because if this object is put into a hash map, then it's very important that it is very important that these constraints are met. The constraint is if two objects are equal, then their hash codes should be equal. So two unequal objects can also have the same hash code. That's not a problem. But when two objects are equal, then their hash code should always be equal. This ensures that we will not be able to put duplicate objects in the in the hash map, for example. Next, we'll look at casting. Casting is basically conversion from one data type to another data type. Implicit casting is when it is done by the compiler or the JVM. So here I'm assigning a int value to a long. This is where implicit casting happens. You can use explicit casting when I take a long value and I'm assigning it to a int. Because long is bigger and int is smaller, you have to make an explicit casting. The other instances where you do explicit casting is when you assign a subclass, a subclass variable to a superclass, or those kind of combinations. Next, we'll move on to arrays. There are a lot of questions about arrays on our channel already. Just look up the guide as well. One of the important things about an array is once an array is created, its size cannot be changed. So once I create an array with 5 elements, it has to be 5. If I have to add an element to the array, I have to create a new one with 6 elements and then copy the values from the original array. So that's the thing. When I create an array, I have to specify a size, and that's the default. It cannot be changed during the array. The default value in the array would be different based on the type. For typical integer values, it's 0, float and double, it's 0. For boolean, it's false, and for object, it's null. In the screen right now, you see how you can use an enhanced for loop to loop around an array. The syntax is very simple. This is the array. I'm creating a variable mark, and I'm trying to loop around it. You can use an arrays.toString. That's a utility function which is present in the arrays class to print the content of an array. So if I do system.out.println marks 5, and marks 5 is an array, it actually prints the object reference of the array. It doesn't really print the content of the array. So if I want to print the content of the array, then I have to use arrays.toString. If it's a 2D array, then I can use arrays.deep_toString to print the entire content of the array. So it would then print 1, 2, 3, 4, 5, 6, which is the exact array that we created. Comparing arrays, also there's a utility function. It's called arrays.equals. So you can use this static method in the arrays class, which is equals, to compare two arrays. Let's end this discussion about core Java in here. There are a lot of other stuff on our channel. Do check them out. Thanks for watching. Bye-bye. I was recently preparing for interviews after a long time. I found it really hard. Core Java, Advanced Java, Web Services, REST Web Services, Collections, Threads, Struts, Spring MVC, Hibernate. I mean, the topic list was endless. I was like Sachin Tendulkar after he stopped batting for 5 years and he was asked to bat again. There are a lot of stuff that we need to refresh on before we attend an interview. I really had to prepare very hard for about 45 days before I felt confident about attending the interviews again. So I prepared a quick refresher, a 170-page interview companion book, along with a set of 25 videos which would help you to really quickly prepare for your interviews. If you're interested, do check those out on our website. Thanks for watching. Until next time, bye-bye.